And for the last part, so because software is interconnected, you have multiple players in the playing field. You have actually a quadrant. So you have the quality of the product. So you want to have a certain threshold for that. You have your supply chain. So open source is like one of the biggest threats in your supply chain. You're getting software from somewhere, you don't know the producers, you're not able to set requirements for it, but you're still using it. And then you also have your relationship management with your supplier. So, for example, Maxxton is a supplier. You can actually say, hey, Maxxton, I want your product to be secure in that way. Can you do that? And go into this discussion. If a product is not secure, it is broken. And that's something that you can always kind of ask to your supplier to be ensure certain levels of security. And then, of course, the vulnerability handling. You have a vulnerability. What are you going to do? And then, of course, yeah, your assets are here the most important part. Now, that's the landscape. But how are you going to define this in your business? And then this picture comes in. Governance is the rule set that you're going to apply, and it's going to translate what you want for your business in a technical aspect. So I want to achieve software that's reliable, usable, and safe. That could be like a governance thing. That you have to translate into practice. And in the practice, you have your developers. They're going to build functional requirements for that, build that into your system. And then, of course, in the middle, software is alive. It continuously evolves. So you have a lifecycle management thing. So it's continuously, the business is also evolving. So you're continuously changing, revising, looking. Do the goals from yesterday still apply to today? And does the security requirement from yesterday still apply to today? Because that might change significantly. And of course, a little bit of product placement. We have a platform that helps you with that. But you can talk to Frank later if you want to know more. This is maybe a picture that everyone knows. Software lifecycle. You begin with your analysis. You want to know what you're going to build. Then you go into design it. You're going to develop it, test it, deploy it, and then you go into maintenance. One big part that's missing here is your security. And when you look at security in the development lifecycle, you can actually match every activity here with the security activity. So first, in your analysis phase, you're going to set your security requirements. Then you're going to do threat modeling. Very theoretically hacking, actually. I have a potential system that would look like this. How would I attack it? That's actually the question that you need to ask. In the development, you then have tooling that does automatic scanning. And because you're going to scan here early, you're going to also be able to fix early, quick, and cheap. Then, in the testing phase, you can go slightly more deeper, get penetration testing done, automatic penetration testing. But it's already quite late in the phase. And the reason the testing is different here and there is because here you don't have a functional product. So you need to have static analysis looking at your code. Here you have something functional. So you can actually deploy it and imitate an attack. So that's why the difference is between those two. Then in deployment, of course, you're not going to stop. You're continuously going to monitor and also going to have a good configuration, not only for your infrastructure, but everything that comes into the outside world, and then the continuous monitoring in the maintainability phase. So each time you fix a bug, it might be a security bug. You should be no difference between both.